My name is Sarah Williams, and I am the Marketing Director here at IQ Power Tools, and I'm joined with Paul Guth, our inventor and CEO.
Welcome everyone. It's a pleasure to have you with us here and take a few minutes and talk about the design process and how we innovate here at IQ. Yeah, a little bit about the IQ story. I tell this kind of at the beginning of each video, but for those that have not heard it, IQ really evolved out of a construction company, masonry and concrete construction company that my brother started, Joel, and that went on for many years. And out of that company, we had needs. We had problems that we were trying to solve, and we went looking in the marketplace. And we were looking for dust collection solutions for masonry saws particularly. They didn't exist, so we started building our own in our shop and started putting them on our job sites, started solving a problem. And then in 2004 we went to our first trade show, sold some machines, and slowly but surely began a business. In 2012 we decided to close down the construction business and focus on IQ Power Tools as just a products business to bring innovative, focused on dust collection products to the marketplace, and that's what we've done since then. So that's a bit in a nutshell our story, and we're continuing on, having lots of fun and innovating and bringing new products to the market, every year really. So here is the 2000 machine, which is one of the first things that we introduced. We needed them on our job sites, and so we started building them. We designed this table that fits on about 9 different brands of masonry saws. We went into manufacturing the large dust collector here to capture that dust. And so that's your filter bags. It has a shaker mechanism. So kind of the same concepts that we followed down through the years, except we just kept making them smaller and smaller. This is the 2000 machine that we developed many years ago.
1000 machine.
I'm sorry, 1000 machine. And then in 2010 we came out with the IQ 360, which really kind of changed the trajectory of the company, because now we're selling to guys in just a pickup truck doing small backyard work and things like that. So that really kind of changed things. And then we sold that for many years and developed then, took all the information that we got from feedback and developed the 362, which we introduced about three years ago. And then of course we got a full line of blades. We got introduced the tile saw about 4 years ago and kind of went into that market, introducing dry cutting, which was a totally brand new thing for tile contractors, is being able to cut dry. But it eliminated the water and solved a lot of problems there. And of course it has the integrated dust collection. Then this year we've introduced the IQ 228 Cyclone. Again, very small portable tile saw. Just another kind of a game changer, and people are very, very excited about that. And then we also have the IQ 426 HEPA vacuum, dust extractor vacuum, that's been on the market for about a year. So that's a bit of the range, and these are the tools that we've developed and innovated over the last 4 or 5 years. So well, it's really as we worked on job sites, and most of the people here that are part of the development team have hands-on experience, and we're trying to solve real life problems out there that we used to experience. Just like we needed these tools on our job sites years ago. We invented them, we solved the problem, and we had other contractors that had the same problems, and so there was a market there. So that's kind of the inspiration, is solving problems, making things that are innovative, creating new things, talking to customers and getting feedback, and they tell us, if only you did this or that, and then we kind of put that on a list, and maybe we can introduce other things that we can, ideas that we can solve those types of problems. So it's really just developing new products it's a lot of fun. This is a very condensed version of the process of how we do what we do. But first, it all comes down to a problem. We identify what the basic problem we want to try to solve, and then we go through a proof of concept we develop a set of design goals. So we identify what are those problems we need to solve, and maybe in one problem there's 50 individual small problems that we got to solve, and so we'll develop solutions for all those little things as we go through the design process. And then we test and verify as we solve the problems, developing, making sure we're hitting our design goals. And then finally it comes down to what is the overall design, what do we want it to look like, get some user interaction with it, how do they react, do they understand how the latches work, how the buttons and the switches and all those types of, and that's called the industrial design. And then we do more hands-on testing, and then we take it out to manufacturing, and then it's more testing and testing and testing until we are ready to bring it to market. So that's a very, very condensed version of kind of what we do. But you know, in any one product, like here's the IQ 228 Cyclone, that's kind of an exploded view. This is actually one of the products that has, you know, some of the fewer amount of pieces, so it's actually more simple in that regard. But you know, that was the challenge with that. In the design goals, we wanted it to weigh 35 pounds. We wanted it to be, you know, hit a price point. We wanted it to, you know, meet all of these things and fit into a size of a box. So those are kind of the things that we set as design goals as we go through and start solving all the problems.
So I see you also have some cool stuff here. Could you maybe talk about the patents and the concepts?
Yeah,
real quick?
as we, you know, part of the process is we, you know, I have, this is my personal notebook, and you know, as I'm traveling around and doing different things, you know, I'm jotting things down. As I go to a trade show, I'll put, you know, comments from end users in here. You know, maybe they have a crazy idea that, why don't you have it do this, or why don't you have it do that? And I'll just make those notes down, because once I hear something, you know, 20 or 30 times, you know, at some point we start listening and go, okay, that's a feature that we think people might want, and where could we introduce that? And maybe it's not even in the product we're talking about, but some future product we introduce it in.
And I can be a witness to that. I've seen it in action, and I've seen it happen at trade shows.
Yeah, so.
And that book's awesome.
And then of course, you know, as part of the process, we're always looking at patents and what is patentable, and you know, we have regular meetings with our patent attorneys to make sure we're picking up intellectual property along the way, because that's something we innovate so quickly we don't even realize that, you know, something might be patentable. We're just solving problems. And then we get the patent attorney, he really kind of interviews us and said, what have you been up to? And we show him, and he starts checking off these different things that we need to start pursuing. So it's an interesting, fun, very dynamic process, and it's a team that is doing this. So. Yeah, so here we have kind of a line of products here, and we call this, for example, this is the Frankenstein. We call it a Frankenstein because you know, we build it very crudely, then we take and start printing 3D models and start taking body parts on and putting different ones on, and so we kind of coined the frame Frankenstein, and that's actually one of our technicians, Tobias, did that. So he calls it. Is that
patented?
Huh?
Is that patented?
No, you know, it's like Frankie. He calls it Frankie. So anyway, you know, we put different motors on it, different filters, and so we really develop the concept, start solving all these problems that we were talking about until we get kind of a group of components that seem to be, you know, meeting our design goals. Then we start doing our 3D printing, which is, you know, right on the other side of it, we have our 3D printer. We're constantly 3D printing parts. And then we'll start making real prototypes and having people, you know, use them, put their hands on them. Like I said, use the latches, the switches, wind up the cord. Does that all seem to be intuitive enough? And then finally we come to the finished product. So you can see there's really an evolution as we develop the product out and to refine it and get to the end result. So this is interesting. If we back up here and kind of break that down a little bit, you know, our 3D printer, which is pretty cool, you know, we'll print out full parts, and then we start introducing metal parts into it, making sure, you know, if it's pulleys or whatever mechanisms are working. And then we start machining parts. So this is a fully machined, you know, prototype here that we'll start doing testing on. So, you know, we go from plastics to metal, you know, some like more crude, like do a lot of welding, and then we go to some plastics, and then we start machining. So a lot of different processes involved. And we do all that right here, and that's something that maybe you guys don't realize is we're right here in California. All of our R&D and testing is done right here and to solve all these problems and bring new products to market.
Can we show them a little bit more about what's happening here in California?
Yeah.
Let's go show them the Frankenstein room.
Okay. It's the welding room. It's
welding room, not the
not
Frankenstein.
the Frankenstein room. We don't create monsters in there, but we're here in Southern California. This is where we supply everything for North America. But again, we do all of our R&D, testing, product development right here. So this is actually our welding room. And here, for example, we have on the welding bench, this has been done for quite a while, but we just kind of put it in here to show, you know, Tobias likes to spend his time welding things. And, you know, he develops things. He likes working in metal. So he puts things together. And then we start putting some 3D parts on here, you know, little guards on here, different cyclones on the inside. So just really getting, refining all the parts and pieces. Honestly, because Tobias likes working in metal. So he kind of begins, you know, we all have our different processes, but metal is a good way to pretty quickly put something together. It's durable, and then we can take this machine and really do, you know, real-time testing, and that's what we did. You know, we put this blade on it and went out and started doing a bunch of testings. Because it's metal, it's very durable, and we can work it. He'll also make lots of different components that go on the inside, so maybe it's just a box, but on the inside we have lots of different types of cyclones that we're putting in there, different filters, different motors, you know, so that's just, it creates a very durable box for us.
What about timeline? About how long does the Frankenstein version kind of take? Does it vary per tool, or?
Yeah, it really varies per tool, but you know, this one, you know, Toby is off camera here. He's a little bit shy. So, you know, this one, Toby, you know, we probably spent a good 6 months with this one. You know, it didn't take long to build because, you know, we can build something, you know, in a week or less, you know, even a few days sometimes. But then testing and refining it, and, you know, how does the table interact, and, you know, do we have a clamp, do we not have a clamp, you know, these different parts that originally were built out of metal, we start 3D printing them and just seeing how they function and refine it. So.
And do you guys kind of focus one Frankenstein at a time, or do you typically have multiple Frankensteins happening?
Well, we typically have one Frankenstein for that particular project.
Got it.
We might have multiple Frankensteins for different projects because we'll move, you know, and develop different things at different times, because sometimes we'll run into, you know, maybe a roadblock and we can't pursue this anymore, so we'll jump over to another product. Or sometimes we're waiting for things to be printed on the 3D printer, you know, and you know, we can work on multiple things at once. But, for example, there's your dust tray, you know, the Frankenstein version of the 228 dust tray. So this is where we work on wood and plastics, you know, as we develop different things. Again, a lot of 3D printing that we do. This is Matthew. He kind of is another R&D technician to help us with the process. So we have, for example, this is a miter table we're working on for the 228 Cyclone, and we have to print it in 2 pieces, so we'll glue these together. So this is a whole prototype, you know, 3D printed model of the 228. These are I mentioned in the Frankenstein, Toby will take and make these metal plates, and then we'll print out different types of cyclones, and then these modules can be just mounted into the you know, into the Frankenstein version. And you know, we got 3 different sets here, different dust guards or blade guards. So, and then we also do some molding. Matt, you want to tell us about what's going on here?
Sometimes we've got 3D printed parts, but if we need either a large quantity or something that we can't, you know, we can only print on this size footprint, so you know, about a 1 foot square. So sometimes if we need to do a larger part, we'll do it in multiple pieces, we'll glue it together, and then we'll make a mold. So for example, this is a mold for a cyclone, and then this is a mold for the tile saw dust tray, and so we'll make a 3D printed one, we'll make a mold of it, and then we'll pour plastic to make a solid plastic piece.
That's pretty cool. I haven't even seen that, and I've been back here how many times?
Yeah, and these are silicone molds, and that way, you know, if we want to go into testing and do some more durability testing before we have, you know, units completed, then we can mold them out and we can get real live testing with, you know, something that's very, very close to what the end product could be before we go to manufacturing. Because, you know, once we go to tooling, it could take them, you know, 3 to 6 months before we get this part, and we want to make sure it's working correctly, you know, much earlier than that. So we'll mold things. Sometimes we're making things out of wood, plastics, in combination of wood and plastics and silicone, and so that's kind of what this room is dedicated to, is working with plastics and wood.
What's that timeline look like? I know you said it kind of varies per tool in the Frankenstein, but what about the 3D printing? Does it take a long time to print? What's that timeline?
Yeah, I don't know. For example, this is, how long did it take to print these parts here, Matt?
These are probably about 6 hours a piece, so it's not a fast process, but if we keep it running 24 hours a day, so we can work our way through parts fairly quickly.
But as you see, this whole prototype here, you know, that could have taken, you know, a week or more of, you know, pretty much 24 hours a day printing in order to get all those parts, and then we glue those all together. So, I mean, the 3D printer is we try to keep it constantly working, especially over the weekend. You know, it can work while we're sleeping. We like
basically an additional IQ team member.
Yeah. So.
You spoke about tooling. Can you maybe explain what that is?
Well, the tooling is, you know, so you can imagine this part right here, you know, we've just 3D printed it, but at some point it's got to go to tooling. And what tooling is you imagine a great big mold that will, you know, close together and have a cavity in there, and then they'll inject plastic in there to produce this part. And that's what the tooling is. And it can take a long time to make those molds or the tooling for all the parts. And then you start looking at, you know, one machine, you know, it can have 500 different parts, you know, and hundreds of those could require tooling. So it gets to be a long process, plus very, very, very expensive.
So it's more cost efficient and time efficient for us to get it right here.
Yeah.
And then take it to tooling.
That's exactly what we do. We want to get it right here, you know, through the 3D printing process, through our molding process, just to make sure we're not introducing changes, you know, down the road. It gets very, very expensive.
So because we want it to be right, we do a lot of testing, right? Yes. Should we go out and take them to the testing room?
Yeah, let's go to the testing area. So we'll go to the actual testing area, and you know, testing is pretty much a constant here at IQ. We're testing new products that we're bringing to market. We're testing just individual components. For example, you saw those 3 sets of cyclones. You know, Tobias will start testing each set of those cyclones and start measuring efficiencies on those and which one is the most efficient. And then we refine and refine till we get to a group of parts that we, you know, think we want to take to manufacturing. So also testing, we do a lot of blade testing. Here's a bunch of cutoffs for our marble blade testing that we've been doing. So we just go get, you know, white marble because it's kind of a challenge for one of our blades. So we're developing a marble blade. When we were testing for the 228, we wanted to test the blade and see how many cuts you can get out of a blade. And so that's almost 5,000 you know, lineal feet of cutting, and that's what you can expect out of a standard blade. And it's just, you know, it's just the cheap red ceramic, you know, glazed tile, 12 inches long. So there's actually, you know, about 5,000 pieces here or more. And then we wear that blade completely out. So, and you know, and that's not the only test we do. You know, before we get to that point, we have done testing, you know, hundreds of test blades in order to get to a refined blade that we think we're ready to go to manufacturing with it. And then before we do that, we do this type of testing. So to make sure we we got the right combination of things working for us.
So a few questions. How do you determine what type of test to, I guess, mirror everyday use? So like for durability and other things.
Well, for durability, you know, a couple different ways. If it's, you know, sometimes, you know, we're doing durability testing on a blade itself. So we want to do lots of cutting, and there's no other way to do it but cut a lot of material. Sometimes it's durability on just moving it around. Sometimes we give it to a contractor here locally and say, hey, use this. How does it, you know, work? You know, did something break? You know, did the knob come off? Did, you know, something simple like that. We're also doing outside, we'll do durability testing with our machines to just make sure they're meeting what we would expect as end users, because we are tool users ourselves, and just make sure we're providing a good product.
And is there like a standard set of tests that we know that we do like these 3 tests for every single saw? Or is it kind of just, it varies per tool?
Here it varies per tool, but then there's a whole nother very stringent set of testing when you start talking about Underwriters Laboratory, CSA approval, CE approval for the European markets. Those we actually pay an agency to go and do, you know, thermodynamic testing, electrical testing, noise testing, all kinds of things. So it meets the criteria for the different markets. So.
Speaking of different markets, what about dust? Can we take them to our next set of testing? How we test to make sure that we're getting as much dust control as possible?
Yeah. So at the core of everything we're doing is, you know, we're capturing dust, and that's kind of our, you know, our DNA is what we want to do. So one of the things that we built is what we call the T&O room. This is actually a replica of a room that they have in the Netherlands, and they use it to test machines that are coming into the Dutch market. And they actually, in that market, test for dust exposure, and they'll give it a rating. So we have a dust monitor that gives you real-time dust readouts. So we can put our products in here, do testing. We can also bring, as in the development process, as we have got different ideas and we're trying to see efficiency, we can bring the products in here and see, you know, is that dust guard more efficient than, you know, version number 1 or 2 or 18 sometimes. So we're doing a lot of refinement, and this room helps us to identify if we're making progress.
And I know you said that this is for T&O, which is mainly Europe, but what about OSHA?
Yeah, for OSHA, then we've generated white papers to show what the permissible exposure level is, and OSHA has set those. So we actually do testing of all of our products. These are air pumps that we'll, you know, put on a person and have them go out and do real live testing. And then we can take that data, send it to a lab, and then they generate the test results for us to see if we're meeting the permissible exposure limits that have been set by OSHA federally. So, and we have all those white papers with that data.
So very cool. So we went over concept, we went over Frankenstein, we went over plastics and testing. So what's next?
Well, next thing, you know, we start, how do we take this to market? And you've met a few of the people, you know, Matthew and some of the other team members, but, you know, there's a lot more behind the scenes that are happening. And so I'd like to kind of introduce you to the rest of the team on what makes this all possible.
Again, thank you guys for joining us, and we're going to take this opportunity to show you the final steps of what happens when we bring a tool to market. So here's our IQ team.
Hello.
Oh, well, hi again, Paul.
Yep, so this is a little bit behind the scenes. This is, like I said, it takes a team to bring these things to market. And this is the team. You know, it takes, you know, a product development team, but then we got to do the marketing. Who's going to create all the artwork for the box? Who's going to create, you know, all the brochures and the information and get that all organized? Who is going to answer the phone when you guys have a problem or want to make an order? And so that's what we have here. We have customer service. Raise your hand, customer service. Okay, we have our accounting team. We have our supply chain team, okay, because those are the guys who are going to take the order and get it out to you. We have Jim Mackel, our president, also running our day-to-day activities. We have our HR person, so, and then our product development team. You guys raise your hand. Some of them are off screen, they're a little shy, and then again, the supply chain, you know, they're the guys that are putting the pallets together and shipping stuff out to you. So again, it really takes a team. Just like if, you know, we develop these machines, and if there was one part missing in those machines, they don't work. And it's the same with the team. We got to have all the components put together, working together to make sure we're putting a good product out and giving you guys customer service. And then after, you know, you have a problem or need some technical support, I forgot our tech support team. That's Kevin there. Where's Bill?
He's on the phone.
Bill is on the phone.
He's working. He's doing
handling
his
the
job.
problem. Yeah. So like I said, it takes a team to keep this thing going and provide good products to our customers. But again, it also takes you guys to believe in us, put that money down to buy a product, and believe in the IQ brand. And hopefully, we're living up to our promises to give you guys a good product, and we'll continue to do that. So that's a little bit about the innovation and how we take things to market. So
we appreciate you guys joining us today.
Yep. And I'd like to thank everybody for joining us. And again, I'd like to thank this team because it's my privilege to be the CEO, but I'm just one and part of the team. And these guys are doing a lot of hard work, and I truly appreciate and privileged to be part of it myself. So we appreciate everybody's hard work, and we look forward to producing more innovative products and showing them to you guys in the future. So it's a lot of fun.
It's going to be a fun few years coming up. Hint, hint. Thank you guys.
All right. Thank you, everyone. Bye-bye.